In the previous video, we had learned about the shape of the orbital. In this video, we are going to be talking about the energy of an orbital. So, the energy of an electron in a hydrogen atom is determined by the principal quantum number. So, in hydrogen atom, the energy order is 1s is less than 2s, which is equal to 2p, which is less than 3s, which equals to 3p, which is equal to 3d. Now, the orbitals, they have, whichever have the same energy, they are called as degenerate orbitals. In case of hydrogen, the difference between hydrogen and our multi-electron system is the fact that the only force in hydrogen is the attractive force between the nucleus and the electrons. However, in case of our multi-electron system, you not only have the principal quantum number, but this particular case, you will have the azimuthal quantum number as well. To simplify this, basically our electrons will not only have the attractive force with the nucleus, but they will also have a repulsive force amongst themselves. So there is going to be a repulsive force between the electrons of the inner shells and the electrons of the outer shells. Okay, so this will lead to a concept called as shielding effect. Now, a shielding effect happens when the positive charge of the nucleus is going to get shielded by the electrons of the inner shells. And that means the effective nuclear charge on the electrons of the outer shells is going to be less compared to the ones that the inner electrons face. But with the increase in number of shells, you also have the increase in number of the rather increase in the amount of positive charge. Generally, based on our shell, for our shells, S orbital is going to have the least energy compared to P, compared to D, and compared to F. But when the energy levels are going to get higher, there is going to be a slight change in the orbital energy. So here, as you can see, this arrow shows the increase in energy. So 1s will have the least energy, 2s, and then you have 2p, and then you'll have 3s, and then you'll have 3p, and you have 4s. You don't have 4p, but you have 3d first. So 4s has lesser energy compared to 3D. So this leads to a staggering effect. And after like the next video, we'll be discussing about the ways by which the rules which govern the filling of electrons and the energies are one of the important ones, or rather one of the rules. Okay, so both attractive and repulsive interactions depend upon the shell and the shape of the orbital in which the electron is present. So if in case of our s orbital, they are a spherical shape, right? So these orbitals will shield the nuclear energy better, or rather much better than compared to our p orbitals, which have a lobe shape, right? So because, and similarly, in case of p will shield it better compared to d. And even though all these orbitals are present in their same shell, the shielding effect given by each of these orbitals is going to be different. Now, due to the spherical shape of the s orbital, the electrons will be closer to the nucleus compared to our p orbitals. P orbitals, if you remember, there is a part in the diagram or the graph boundary surface diagram where the probability of finding the electron was 0 in the center. So these electrons will be in the vicinity of the nucleus, but they won't be very close to the nucleus. And even, so compared to d orbital, these are better, whereas d are going to be further away. Now, the so this means that in a shell, as the the principal quantum number, the ZF, that is the effective nuclear charge, which is experienced by the atom, by the electron, decreases with increase in the azimuthal quantum number, which means that S orbital, which has the least azimuthal quantum number, has the most Z effective, that is the effective nuclear charge to it. And as you go upwards, it will decrease. So SL orbital will be more, electrons of the S orbital will be more tightly bound than P, which will be more tightly bound than D. Now, the energy of the electrons in S orbital is the least, as we know over here. S is going to be the least, P is the next, D is after that, and F is after that. So, because there is going to be a difference in the shielding effect of all of these electrons, the lower the value of n plus L for an orbital, the lower is its energy. So if two orbitals have the same value of n plus L, the orbital with the lower value of n will have the lower energy. So this basically means that when you have the values of the azimuthal quantum number and the principal quantum number, as the total of them is low, the lower will be its energy. So let's take this. So the value of the principal quantum number is 1. For S, it is going to, the azimuthal quantum number is going to be 0. So 1 has the least amount of energy. 2 plus 0 equals to 2. That is more than 1s. Then you have 2p, whose azimuthal quantum number is 1. So 2 plus 1 equals to 3. Okay, but the thing over here, if you see here, is that it says that if the value of two orbitals is equal, the value with the lower value of n will have the lower energy. So here, if you notice, our 2p orbital has 2 plus 1 equals to 3, and 3s has 3 plus 0 equals to 3. So both of these values, I mean n plus l values are the same. But here, the principal quantum number for the p orbital is 2, and for the s orbital is 3. That is why the 2p orbital will have a lesser energy than 3s. Now, similarly, if you take 3p, 3 plus 1 equals to 4. Again, 4s, 4 plus 0 equals to 4. So, but the principal quantum number for the p orbital is 3, which is less than 4. So, 3p has a lower energy than 4s. So energies of the orbitals in the same subshell decreases with increase in atomic number. Now, and this is because the energy of the 2s orbital of hydrogen atom is greater than that of the 2s orbital of lithium. And that will be greater than 2s for, sorry, that will be small, that will be, yeah, greater than that of 2s of sodium. So as we go up the atomic number, the energies of the orbital of the same shell will decrease with increase in the atomic number. So with this, we finish the energy of the orbital in the hydrogen atom and the energies of the orbitals in multi-electron system. So that particular diagram is very important, that the energy diagram, because it helps us in understanding the filling of the electrons, or rather the electronic configuration. In the next video, we will be discussing the 3 rules that are required, or not required, sorry, the 3 rules that are followed to fill in the electrons in the orbitals. Do check it out.